Hello, I'm Conrad Wolfram.
And I'm Jon McLoone.
And this week's Computational Conversation podcast is a discussion on both of our favorite new features in version 14.2 of the Wolfram Language, which has just been released.
Yeah, it's always the big highlight of 6 months period for us. It's a lot builds up to it, and it's at the point that we're talking now, it just came out a couple of days ago.
Yeah, so this is our biggest version release of the year. Actually, I think it's a pretty big release, even multi-year. And we'd like to talk about which, out of all the numerous features, we each find most exciting if we had to pick only one. So, Jon, of all of the newly released features, which is your favorite and why?
Well, I think for me, this is an occasion where the big headline feature, when there is one in a release, actually aligns with my personal interest. So it's the tabular framework, which I should probably explain briefly, is that we've been able to do all kinds of amazing data science for a long, long time in the Wolfram language, but there's a subgroup that comes up a lot, which is tabular data, where you have column-oriented data, and there's a whole bunch of things that if you know your data is column-oriented, where you have rows of observations and each column is some kind of feature that are generally similar, the same information each time. There's a whole bunch of things you could do much faster, and you can express much more elegantly without having to worry about, is it high dimensional ragged arrays of key value pairs and all kinds of complicated things that might go on in data. So the kinds of things that people use Excel for, because that is locked into that world of tables. We've got now a new framework that allows those kinds of column-wise operations to be done both, in some cases 1,000 plus times faster, because you don't have to worry about the differences between the rows, and also really kind of be able to express yourself elegantly and talk about the data in a very correlated.
Yeah, I mean, so the summary there is you can deal with standard data people are used to, particularly from Excel, extremely easily, and it just sort of works as you'd expect it to, which I guess we had associations before, but they didn't quite,
Yeah, well, there's two parts to the story. One is, can I express myself easily? And with that kind of assumption of tabularity, the code is really quite elegant. I can just say in one line something quite exotic, making things like pivot tables that you could do before, but they were kind of fiddly to do. So it's just really speeded me up. And then the other part is a pure efficiency, computational efficiency issue that it doesn't matter when you've got a million rows of data or less, because everything's kind of fast. But when you're starting to get into multi-millions of rows of data, then every time you do something, if you don't have full efficiency, it breaks your flow, because you've got to wait for a minute for the computation to happen. And the fact that it's all much faster means you're still in the zone when you see the results and you're moving on to the next thing. And I spend a lot of my time actually doing data science, so this has been a perfect alignment for me. It's exactly what I personally needed. So
well, good.
That's
nice to hear.
But that's why it's top of my list.
Okay, well, that's great. So for me, I'm going to pick the obvious thing, which is Notebook Assistant. Notebook Assistant is our development of connecting, in a sense, the LLM world, the modern AI world, to our notebook interface for generating expressions and code. And we've had pieces of this before, but this is a very nicely put together version of this, which is far beyond just connecting the two. And it's amazing. So, I can ask it, I can utter things, and I can get a piece of Wolfram language code straight out. It's sort of nicely interfaced, right? Because we've got a sort of separate notebook to one side, the default setup. And you can sort of, in a sense, ideate in that notebook and then get it automatically to insert and evaluate into your main notebook if that's what you wish to do, or you can do it all in your main notebook. The point to me is that it's starting to get a good familiarity with both, obviously, our language, which it knows well, but also how you would interact with it. And here's the key thing that I find exciting. In a sense, what LLMs have done is to join the computational, the human language world. I mean, that's one aspect of what they've done. I am not a believer, as some people are, in the fact that we can dump abstraction as a way to represent things or interact with them as humans. I think we do need that alongside our more fuzzy linguistic skills. The thing that I think we've done here is to piece those together so that you are fully optimized for computational things in both interfaces. So, I utter something in English, I get a program out. The program might be exactly what I want, or it might not be. I could either utter more to change the program to something I want, or I could just look at the program, and because it's Wolfram language and because it's short and it's very, sort of, it makes sense in what it says, it, um, you can immediately go and edit that code directly. So I can choose whether to edit the code or go back to the English and recast it. And I could do that in any language, except that in our case, you're much more likely to be able to do it because you can actually see it immediately. I've had people look at it and say, "Oh yes, I don't know anything about Wolfram language, but I want the thing to look green, not red. So let's stick red in." And it's obvious where that goes.
If you think about different audiences for this, I think I'm at the least interesting end of that audience spectrum. As somebody who thinks, I've been doing this for 30 years, I think Wolfram language almost before English sometimes if I'm thinking about computational problems. So I only make the very lightest use of the assistant. But I wonder, do you think out of the other audiences, we've got people like complete outsiders? So when you get the trial version of Mathematica now, you get the notebook assistant, and to get you over that I have no idea what I'm doing barrier and be able to use it. That's one audience. Another audience are those kind of casual users who, they can use Wolfram language, but they don't know the full range of thousands of functions. They don't know that there's a perfect function in there for doing the thing they want to do. And this can help to kind of make them more expert, make light users into experts or non-users into light users. Which do you think is the biggest win in terms of?
I think even expert users, it's just like, because, oh my gosh, out of the 6,000 plus functions, I didn't remember this one at this moment. And so adding the vocabulary sometimes is pretty helpful. I mean, it's funny where this sort of cuts, because I think, it's interesting. I had a project some years ago, well before modern AI, which was because I spotted the following workflow problem we have. We have an awful lot of functions, some of which just do stuff. And in a sense, we've added functions where we can see a workflow that we just want to encapsulate in one function. So if you're in luck, I mean, this is pre-AI, pre-notebook assistant. If you're in luck and you can just sort of, you go into a documentation, you look up, I would like to do face detect, okay, for example. You can just basically do it because it's one function or that function wrapped in something to do something useful. It's very straightforward to find that, to paste it in, to do something with it. The difficulty arose where it's 2, 3, 4 functions strung together in some sort of workflow. And if you're not particularly experienced with the language, you find it perhaps harder to get to an experience level that allows you to see that quickly. And I tried to see if we could compute that. So in case we don't have a function, could we compute how to get from one direction to another? And we didn't really succeed in that fully. Now, in a sense, Notebook Assistant is the ultimate version of that. So it's basically saying, okay, you've got this general fuzzy thing you want to do. I now want to piece together these different functions that we've got at a high level to get you to that output, at least roughly. And I think that cuts in various ways, because I think that's taking people who know absolutely nothing about the language and getting them to do something with it. I think it's helping people who have some experience and have ended up, because I think one thing we often see is people have ended up doing a rather narrow channel of the language because that's what they got used to. They didn't really broaden their experience. It's like you I don't know, this is probably a bad example. You speak in English only in the present tense because you just kind of didn't know there were other tenses to use. And I feel that it will help a lot with those sorts of people. And then periodically there are surprises for experienced people like you, where it's just like, again, one had forgotten a facet because there are many facets.
Actually, I think for me, when I've been using it, the way I find it most useful is really just patching over my general incompetence, which is you write 3 or 4 lines of code and they don't work. That's in any language, that's the process, and then you look at your code and you have to figure out why. Just being able to say to it what I do wrong, and it says, oh, you can muddle up select and cases that are both ways of selecting data, but one takes a pattern and one takes a the kind of trivial mistake you make, or balancing brackets wrong, so there's too many arguments for something. Up to now, our help there has been syntax highlighting, so you color wrong numbers of arguments, but there are plenty of cases where it's syntactically correct but it's not really what you wanted, and just being able to say what did I do wrong, that's pretty useful. But at my level, I'm not using it to synthesize code very much. It's more fixing what I've done wrong and debugging. Or
I mean, I think the key point here to me of the whole thing is abstraction still matters. We're not going to get away from that for many things. We'll move the bar to just being able to speak to the computer and get it do everything, but we're not away from that because abstraction is important in for many things. That's why mathematics has been important in many ways. It adds a power and precision that you can't necessarily get otherwise. So that's not going away. So the question is, how do we optimize that? I think this is a great optimization of that. And so anyway, that's that. I wanted to ask a completely different thing from
well, let me give you one that's a completely opposite end of the spectrum, because I think in the end we both between us like the headline features of this, and there's several hundred new functions in any release that we come up with. So I tried to think about some where no one will notice, but to heavy users like me, they're really neat. And I came up with two examples. One is a function called failsafe. And failsafe is really just finding a way of packaging up into a word that seems reasonably meaningful, a paradigm that if you write bulletproof code, you're constantly having to do over and over again. So it's really nice when the language takes care of things that are patterns that you idiomatically end up doing. And to explain it, what it is that quite often you do things like apply a function to a bunch of data. And so let's say I want to square root a list of numbers. That's trivial because we do vectorized operations. You just say square root the list of numbers. But if that list came by some process, like it came from some piece of equipment, it might be listed with things where there's been failures. So missing data, or something went wrong and you've got $failed, our symbolic way of saying a failure, or other kinds of bad things. And failsafe, you just wrap around your code and it automatically does that kind of, if it's gone wrong, then pass forward the error. But if it hasn't gone wrong and it's the kind of thing you can compute with, then compute with it. And it's not having to list your code with checking things gives you much more readable, concise code. And in a similar vein, it drives me mad, particularly in other languages, but when we don't live up to our own goals of making things fit together nicely. So there's a whole slew of functions that work on images and didn't work on video. So you could do barcode recognize on an image. You couldn't do barcode recognize on a video. You had to break the video into frames, barcode recognize each one, and then potentially put them back together as a video if that's what you wanted, or take a time series. And I just hate things that don't join up. So it's really nice that all of those now just work, and it's that kind of just work mentality of that it makes, I think, Mathematica more than just the sum of its parts. So every time we polish out that automation between different kinds of functionality, I just love it. I don't think anyone will notice that at all. But when you do something,
little details make a big difference to the workflow.
Well, especially when there's thousands of them, they really add up. If you spend all day going, oh, that doesn't work, I have to do this. Whenever I have to do some open source thing, it's full of that. Oh, I'm sorry, you expect that to work with a string, not a number? Well, you're going to have to write.
Yeah, it's amazing. I mean, one of the things I find funny in the world, and particularly, I mean, honestly, and particularly in the world with fairly highly paid people doing, programming and the like, is how much people will put up with utter shit in terms of stuff that doesn't fit together. I just don't get it. I mean, it's like, if you look at, even if, and we've had this argument sometimes about open source things, it's like, if you just look at the money and you're a commercial company or a government entity or even a university, right? And you just look at, it takes people many, many times over to grind through this multiple times, and they could just do it much quicker. And maybe they need to pay something for the software, effectively pay for the workflow to be much better. But I mean, even if you just do the computation on a few days' work, it saves money. And it's funny how people don't compute it that way. Now, of course, there are other issues sometimes, people feeling like they might get locked in or some such thing. But I mean, I think the problem now is that, as we've discussed several times, you're locked into an open source thing because you've got all this sort of crud to make it work, which in a sense is locking you into a system, because then you have to undo the layers of crud in order to actually reuse it often. So yeah, I mean, you're right. One of our key things is to try and make sure these workflows are really hammered down to a point where they're very clean. What we're trying to do is complex often, so you can't, it's not like, well, you could just have a lovely, people say, why don't you make everything a sort of slick Windows interface, to do everything? Well, you just can't do that for the number of things. It just isn't a good interface modality for the number of things. Now, I think the modern type stuff in and talk English is quite a good modality for many, many things, but not, as we talked about, for
Yeah.
all abstract types of things.
So I think there's several reasons on why people put up with it. One is that I think programmer types are quite logical. So if they're told this function only works with arguments of this form, they go, okay, I get that. I've been told. So they just accept the reality with which they're presented. Some, I think, is because people realize that the actual permutations of making everything work is really actually quite hard. There's a lot of work to be done to think of all the cases and automate them all. And people try and go, well, of course that wouldn't work because that wasn't the obvious use of the function. I can understand why it would be like that. And then particularly, as you say, in the open source world, I think people accept it more because it feels a bit churlish to complain about free things not being good enough. You know, if somebody washes your car, you don't want to say to them afterwards, well, thanks, but actually that was rubbish washing. I would have been better to take it to the car wash. It feels kind of a bit mean. And so people put up with more because they can tell themselves, well, at least it would, you know, what do you expect? It was free. But I think it's one of those things that when you are used to it, and we aren't used to it enough, things just working and this is so, being at Wolfram for so long, that's why I get kind of frustrated when it doesn't just work, because I'm used to all the things that do just work.
Yeah, well, I encourage you to make a fuss about it.
I report everything that happens like that, saying, why on earth does this function not apply in this case? Because it's obvious what the meaning should be. And
I'm sorry, I was just imagining a philosophy essay there, nerds are logical, an Oxford philosophy essay for students. But anyway, we were on to sort of things we found interesting in the release, which are not necessarily sort of the mainstream things. So one that I found interesting is we have sort of PDE specialized for magnets and magnetism. We're talking about static or quasi-static, not fast-moving circuits and things. But anyway, I did find it very nice just to see the fact that you can put flux lines around any shape of magnet immediately, effectively, and it just works. And it's kind of
you're
nice
a physicist by background, so I guess that's also more your world, because as a mathematician, things like magnets feel far too practical.
Magnets are pretty cool, I think. And a completely different thing, which is actually not my area at all, probably more your area, but I'm not really a games player or a game theory person, but I did like the new matrix and tree game visualization features that seem really
yes,
nice.
as you know, I am quite into game theory, so I haven't actually explored that thoroughly yet. I think it's kind of fun that we got basically a full coverage of classical game theory, everything you would want. There are other kinds of game theory, but yeah, it is all that kind of Nash equilibrium stuff was stuff I really liked at college. So I will get into that, but I'm not doing any projects in that space at the moment, so I haven't had the time to really explore it. And of course, just a reminder, Nash equilibrium, that John Nash, subject of the Beautiful Mind film, who invented that branch of game theory, actually was a really keen mathematical user. I think we both saw him speak about his mathematical use back at
in London.
London Mathematica Conference in about 96, something like that.
Well, I don't know. It was just after. I remember it was after A Beautiful Mind came out. Because sadly, he and his wife have died. I think they possibly died in a car accident at some point, but sometime after that. But I'd asked him I remember asking him at that, what was it like having a movie made about you? And he said he was very concerned it wouldn't be funny enough. So anyway, it was very nice to meet him, and yeah, he was a very keen user of our technology, and nice to meet him and his wife as well. And perhaps we should just spend a minute off topic. DeepSeek has just emerged from China as a rival AI, in a sense, to the whole American entourage of ChatGPT and various other versions. And I suppose the big thing is that apparently, and I don't know how confirmed this is at this point, it has been incredibly cheaper to build and also incredibly cheaper to run per query, and seems to be producing rather similar results to these mainstream ones, which take a lot of power per query, and have had massive investments, where this seems to have had a rather smaller investment. These all have to be taken with.
Yes, it's early days yet, and
it's early days to know.
It quite lives up to its hype, but
well, not only whether it lives up to it, but also whether the parameters of its inception are in fact fully accurate. The thing I found interesting about this, in a way, is we've had this extreme, excitement over LLMs, which is very exciting. I mean, you just look at them and it's just amazing to see what you can get out. But I'm worrying people have got a bit blinkered by the mechanism exactly that they're running and the way in which they've set themselves up to improve. And this is a pattern of technology sometimes. I mean, one of the things we've been saying for a long time is, we have an alternative route to get some kinds of answers, both allied to these LLMs and, with our sort of deliberate symbolic computation. And I just wondered whether you had any reflections on that with respect to this news.
Well, generally, I think we're going to see this, whether it's as true as it's claimed here, it does seem to be a trend towards figuring out how to make these models cheaper in power terms and money terms. And we're going to see that trend. We're going to see a deflation in the cost of LLMs, and probably before too long, decent LLMs running locally that can do more powerful things. So whether or not this is as great as it claims is in a direction we're definitely heading. So that is got to be a good thing, that they are certainly useful. And the first feedback, I haven't played it with us this morning. This was literally news today, wasn't it? And but I have had one of my team playing with it already, and they gave positive feedback that it does seem to be a decent model and it's freely available and useful. I know we have an international audience, but for me, the phrase that springs to mind is "horses for courses," which I suspect is a bit of a British idiom, but it's using the idea there is no one tool that is the new thing that replaces everything else. You use the right tool for the job, or the mix of the right tools for the job.
It's
that's totally the way I see LLMs. They are doing things that, frankly, are amazing compared to where we were 3 or 4 years ago. But for other things, they're terrible, and you just have to put them together with the right assembly of components to solve the problem that you want, with the fluency and the accuracy at the same time. And from my point of view, the thing that's really exciting for us is the strengths and weaknesses are almost the complete mirror image of Wolfram Language strengths and weaknesses. That we are great at computational thinking type problems, data-driven problems, factual things, models, but we've always struggled to do a good job handling unstructured natural language. Wolfram Alpha does a fine job on short phrases, but being able to apply that to paragraphs, books, text en masse has always been beyond reach. LLMs just do that wonderfully.
Yeah, I mean, look, sometimes technology come along and they're just better than what came before. I mean, that happens periodically. Yeah. Mostly, as you say, it doesn't happen. Mostly, there's a new area or an area that's done much better, but there's some other areas which are complementary. As you say, in our case, with what I would call a symbolic AI of Wolfram Alpha and the whole computation space, which I consider as a sort of underlying technology which enabled AI, as in enabled LLM type AI, I think they are very complementary, and I think people need to remember that. And this reminds me a bit, and I think maybe we've covered this before, of when we were newish at being symbolic as opposed to just numerical computations. Although there had been symbolic systems, but they're kind of weird because they were symbolic only systems, more or less, which weren't really allied to, it wasn't all of computation. It was kind of like, you could either do stuff numerically, or you go a completely different system, totally unintegrated, and do some stuff symbolically, although not mostly terribly well. But people have forgotten about using symbolics because numerics have been so successful with computers. And I feel slightly the same as something's happening here. They've forgotten about deliberate computation some of the time because they can do such nice LLM based results, but that isn't the whole world. And I think that the DeepSeek thing, although it is working on the same basic technology as I understand it, it does remind one that these step changes, you need to look from all angles at these things. And I think it's exciting to see how people are using our technology allied to LLMs more. I mean, even in this notebook assistant inside our own technology, but beyond that, in what people are actually actioning outside.
I think particularly this hype cycle has been accentuated by the speed at which it's rolled out, because the derivative seems so sharp. The people saying, well, if we've gone from nothing to what we have now in just 2 years, it's going to do anything and everything and be the superhuman super intelligence that can dominate in the entire world in just another 3 or 4 years. So it feels like we're on such a trajectory that it must be the solution to everything. And I think it's going to take people a little bit of time to realize this kind of constant trying to flog it to say, oh, it's really getting better at maths, when all it's doing is getting better at maths problem it's seen before, which is the whole point of maths, the whole point about computation is to give answers to things you've never seen before. And the fact that most of LLM's intelligence is driven by experience rather than by method means that it's only ever going to be able to do the maths that it's sort of seen before in one form or another. So that feels like a dead end to me, but it'll take people time to realize it.
Good. Well, human experience tells me that we've probably come to the end of our time on this. So until next time, we look forward to seeing you again on Computational Conversations.
Bye-bye.